All right, well, let's just do a whole bunch of polynomial examples of integration. And we're just going to use this formula there and the same formula for IB. All right, let's say we've got f dash of x is 3x squared plus 2x plus 4. And we want to integrate that. We want the original equation. So we need to integrate it. Okay, what happens? Well, the 3 will stay there. The x will stay there. And now this 2 up here increases by 1. We add 1 to it to make it a 3. And we also have to divide by that. And then we have this one here. So there is a 1 there. So 2 stays there. The x stays there. The 1 increases by 1. So it's squared divided by 2. All right. This one here, if you kind of think 4 is equivalent to 4x to the power of 0. Because x to the power of 0 is 1. So, if we integrated that, the 4 will stay there, the x will stay there, 0 plus 1 is 1, divided by 1, that's 4x. Okay, so now we can simplify it a little bit. The 3's will cancel. 3 divided by 3 is 1. The 2's here will cancel. Plus 4x. Have we forgotten anything? Which is yes. We always have to have the plus c. Always, always, always. When we differentiated this, we would have lost a bit of information, and we have to sort of say, okay, there's something in there that we can never get back if we're not lucky. So we always have to have that plus c. All right. Let's do one more. So let's do it in the form that they give it to you in IB. So we've differentiated something, and it was 4x to the power of 5, that's a terrible x, plus 3x to the power of 4 minus 6x squared plus 2x plus 3. Just standard polynomials. All right, so when we integrate this, the IB people, when we integrate dy dx with respect to x, we get back y. So the 4 stays there, the x stays there, and the 5 goes up 1 to 6, and then we divide by 6. Okay, the 3 stays there, the x stays there, the 4 goes up 1 to 5, and then we have to divide by 5. The minus 6 stays there, the x stays there, the 2 becomes a 3, and then we have to divide by 3. And I'm just going to need to delete that because I'm going to run out of space. Come on. All right. The 2 stays there. The x stays there. What's up here? Well, there's a 1 up there. So now it has to be squared. We divide that by 2. And then we have a constant. Now it has to get the x term. And don't forget the c at the end. That constant. All right, can we simplify it? Yeah, we can. So that's going to be, I mean, we can put it in this form. 2x, 6 to the x, plus 3 over 5 x to the power of 5. 6 divided by 3 is 2. 2 divided by 2 is 1. Plus 3x. And don't forget the c. One more. Yeah, okay. Let's do another one. So we have f dash of x equals, help me out, 10x to the power of 14 plus 7x to the power of 11 minus 400x cubed plus 2x. All right. When we integrate it, we use that little apostrophe. The 10 stays there. The x stays there. And now the 14 increases by 1 to 15. And now we have to divide by 15. The 7 stays there. The x stays there. And now the 11 here goes up 1 to 12. But we have to divide by 12 as well. The minus 400 stays there. The x stays there. And now the 3 goes up to 4. And then we have to divide by 4. And now the 2 stays there. The x stays there. The 1 becomes a 2. Then we have to divide by 2. And don't forget the c. All right. Can we simplify it any more? I think 2/3 x to the 15 plus 7 over 12. 7's a prime number, so it can't simplify anymore. 400 divided by 4 is 100. X to the power of 4. 2 divided by 2 is 1. Don't forget the constant. So far, so good. In fact, yeah, that is pretty much